Welcome to this episode of Ventures with David, a podcast focused on concepts in product management, data, and tech. Today, I'm kicking off a series of focus on natural learning processing and generative AI, and I want to bring you the basic concepts in the context of reading papers that convey important ideas in this field. I believe that being able to read these papers, it's important because both relevant industry players and scholars are pushing constantly the frontiers of generative AI and AI in general. And being able to read this is a great way of keeping up, of trying new capabilities and learning how to build with these technologies. So in the first part of this conversation, I'm going to provide you the basic concepts you need to enter the next part, which is where I have a conversation with Jaehun Jung, the author of this paper you're seeing on my screen. In this conversation, we connect the key ideas of this paper to the current moment that generative AI and artificial intelligence is passing by. I hope you enjoy this chapter and looking forward to your comments. So let's get started. What is distillation? When you hear the word distillation in the context of NLP, what matters is the fact that you want a teacher model, like normally a bigger large language model, such as ChatGPT 3 with 175 parameters. When you hear the word parameter, these are like the neurons that help the model perform several tasks. You want this teacher to transfer knowledge to a student. Say a model that doesn't have the 175 billion parameters, but has 70 billion. What do you want? What is the goal of this transfer? Running an app with ChatGPT 3, which is all dated, it's a huge model, but the latency or how fast the model responds to the user is not good for the user experience. So by training this model, you might improve the latency of this small model to respond to the user. So you gain velocity, you gain speed in getting the answers for the user. That's distillation. Now, a concept that is relevant here is what they found is super interesting. So I want to start with an analogy for you to present a nutshell of this paper. So basically, all of us, we have been exposed to a situation where a teacher asks us something in a test, or we're cold call in a class. We don't know what to respond. We get freeze, right? But what happened when we are asked to expose our knowledge in a more chill, conversational context? Perhaps we might excel, we might respond because we are more relaxed. The same happened here in paper. What Jaehun Jung found was that ChatGPT 2, which in this case is going to be the teacher, is going to be a bad teacher, a very limited model. ChatGPT 2, when asked to paraphrase a sentence, it sucks. It produces options that are not connected with the original sentence. For example, if I say, I want to go to Hawaii, instead of saying, I really would like to have a trip to Hawaii, it will say, I want sandwiches, or I want to learn French. It will not produce a good paraphrase. But what they discover is that ChatGPT improves the quality of paraphrasing when it is asked to continue the conversation based on an input. I want to go to Hawaii. Instead of that, if I said, ChatGPT 2, what would you say next after I say I want to go to Hawaii? So in that context, in a more conversational context, ChatGPT 2 produces better candidates for the paraphrase exercise. And this is relevant. Why? Because we can use ChatGPT 2 to basically train a student in either summarizing or paraphrasing. In other words, we are breaking the paradigm that we always improve the quality of these large language models at performing paraphrasing or summarizing by using a big or great teacher, such as ChatGPT 4 or ChatGPT 3. We can use a bad teacher, and that bad teacher can create the conditions for a student to specialize in summarization or paraphrasing a sentence. In other words, paraphrastic proximity means that when we ask ChatGPT to continue the conversation, such as, I wish to visit there sometime, ChatGPT might show Options such as visiting there is in my bucket list. I don't want to sit in a plane for a long time. I hate a long flight. What about you? The gray areas represent sentences that GPT will use to continue the conversation and are closer semantically to our original sentence. And this happens in a normal conversation where we're talking to somebody says, "Oh, I'm feeling sad," or "I'm feeling happy." We try to paraphrase, sometimes we try to paraphrase the input of this person to connect and to continue with his or her thought. So the same happens here. They found that when asked in a conversational manner, ChatGPT paraphrases or finds better candidates for paraphrasing. So in the traditional distillation path, we have a teacher model, right? We have ChatGPT for teaching as a model. This process per se is more expensive than using an impossible distillation. And it looks with more steps, but remember, we are reducing costs and being more efficient by leveraging a limited model to transform a student in a good paraphraser or summarizer. So basically, the medical teacher, in this case, ChatGPT 2, produces candidates for summarization or to paraphrasing a specific sentence, right? And generate, let's suppose, 100 outputs. Then we involve a judge, right? Which could be another LLM. So this LLM will judge if it is a good paraphrasis or if it is a good summary, right? And then we filter the good examples. We give that to the student and train the student on the best examples produced by ChatGPT 2. Why do we do that? Because the trained student, the small model, the 70 billion model, initially does not know what is to paraphrase. It's not specialized. So if we give the input, such as I want to go to Hawaii, it might produce disparate outputs. By producing bad examples and then filtering the best ones and train the student with the best ones, we're increasing the capability, the summarizing or paraphrasing capability of the student in a cheap way, in a cheap manner. The student afterwards generating new outputs. And then again, we filter the best student outputs and train the student until something happens, which is, you have here two graphs. So in the right, you have that until the impossible T5, which is the student, it has 0.777 billion parameters, basically outperforms the T5, right? The student model without the training on the best examples, and the teacher, which is at GPT-2, 1.5 billion parameters. In other ways, the student beats the teacher. So in yellow, we see in two stages, the T5 stage 1, which is when we produce the first outputs, filter through a judge those outputs, and then put back those outputs to train the student. It already improves the capability of paraphrasing using a metric named the Bird Eye Blue score, which basically analyzes how semantically similar are two sentences, right? And we do that until a point where the student improves not only in stage 1 blue, but also it improves the ChatGPT 2 Bird Eye Blue score. So those are the main concepts. That's pretty much it. I hope you enjoyed the conversation. It's, for me, a great exercise to practice all these concepts, and perhaps I'm committing some mistakes. It's also a learning experience for me. Let me know in your comments, and see you soon. Bye. I am pleased to be here with Jaehun Jung. He's a fourth-year PhD student at the University of Washington. He is studying a doctoral program in computer science. And the reason why I'm interviewing him is because I think his paper was interesting because of the current affairs in NLP. We are seeing that not necessarily by increasing cost and investing more, you improve the quality of the models. Rather, if you can do some improvements based on the quality of the data, you can improve the qualities and the skills of these models. So Jaehun and colleagues published in 2024 a paper named Impossible Distillation. And I want to welcome Jaehun. Thank you for your time. How are you doing?
Thank you, David. I'm good. How are you?
I'm doing well, happy with this conversation. I would like to start asking you about one of the building blocks of understanding the concept of impossible distillation, which is the novel paper you published back in 2024. What is
Mhm.
model distillation? What does it mean for listeners new to compression? Thank you.
For sure. That's a very good question because I guess even the researchers working on the frontiers of models, AI, and deep learning, they don't really have a very good technical definition of what defines distillation or compression per se. Compression seems to be a little more higher level concept than distillation, and that compression is just a general term to refer to techniques that try to compress the scale of the model that we're trying to use, while distillation could be just a one way of doing it. Distillation dates back to 2015 or something paper from the Godfather, Jeffrey Hinton, who first stated, surprisingly, if we not just use human labels to train a model, but if we train the model with, say, a classifier's output distribution as a label to train another student model, then the student model gets better than just using human labels. So in the context of NLP, there has been a lot of variants of this high level idea. By we could immediately imagine now that we have language models that are capable of generating sequences, we could adapt this idea of distillation by defining some teacher model, which would be presumably a larger, stronger model. You prompt the model in a specific way to come up with good quality generations as the data set, which we'll use to train a student model in the hope that the capabilities of the student model on that task they're generating the data set for is actually similar to what teacher model was capable of. That's the gist of distillation in NLP.
What you mentioned is relevant for the current moment of NLP models because I guess by producing this synthetic data set from the teacher, you can
Yes.
reduce costs in terms of not necessarily increasing inference power, but rather than focusing on the quality of the data. I want to ask you about paying attention to the quality of the data and what details are relevant for distillation in particular.
The quality of the data has long been the bottleneck of training good models, not just in the context of distillation, but even when sourcing the data set from humans in traditional ML. I guess it's no secret that the key recipe in training good, capable language models in the frontier lab is not some specific methodology or novel training recipe, but it's more on the infrastructure and the data they have. So, in the context of distillation, a couple questions. One, if we want to distill from a teacher model to improve the student model, what kind of inputs do we have to give in to the teacher model in order to generate the sequences to complete this synthetic data? Second question would be, how are we going to specifically generate more samples, more generations from the teacher model, given these fixed set of prompts? Are we going to improve the capability of the student model? Qualities are around the place when defining this pipeline of distillation, and especially when the teacher model is not really good at the task at hand. For example, in the setting of the impossible distillation, where we considered weaker model as the teacher,
Mm.
where we are supposing what would happen if even the stronger model is not really capable of this task? Can we actually improve the capability by doing something on the data set? If we just naively prompt the model to do something similar to that task, then presumably the output will be garbage. So training on that garbage will lead to no improvements, basically. So the intervention that we are doing related to those two questions that I mentioned earlier is all about improving the quality of the outputs that we're going to get as part of this distillation.
That makes total sense. And having clarity on the inputs. I don't know if you experienced this, but in my short journey in NLP, having clarity on the inputs, it's a little bit confusing, right? So let's suppose you want to improve one downstream task, such as summarizing. But summarizing has many contexts, right? One thing could be summarizing the context of a data set that complains from customers or 19th century literature. How do you get clear inputs that could help us improve the data set and the capabilities of a hard problem?
Right, that's a great question. And I guess the best answer to that is that there's no good answer to that. Um, I guess that's the reason why, as I said, Frontier Labs have their own data recipe that they don't really share in their technical report. In terms of summarization, maybe I could say that there might be two big dimensions. One would be diversity. As you said, there could be very old text from, say, 13th century or some random past time, while we might want to train the summarizer on a very recent document about DeepSeek R1, for example. How are we going to cover all these a vast space of the distribution of documents we might consider as an input? There might be diverse strategies. If you have a very specific scenario where you want the model to excel, then focusing on that domain would be the best strategy. If you want a tech report summarizer, then focus on the tech reports. But if you
Mm.
just want to do a generalizable, if you want a generalizable summarizer, then the best strategy would be just being as diverse as possible. But here, although in summarization, it's relatively easier to define diversity. For example, we intuitively have an understanding of the fact that 13th century old document is different from DeepSeek R1's technical report. But in many other cases, in many other tasks beyond summarization, even defining diversity is hard. I did recent work on how to measure data diversity in a meaningful way. I guess that's an interesting research question actively under exploration by researchers right now. The second part is actual granularity of the inputs. If we're generating both the news articles or some document that we want to summarize along with the summary, then we are
Mhm.
basically relying on the model's capability generating the documents. If the document is completely out of, if the domain we're targeting is completely out of distribution to the model that is generating it, then this model generated document would be very unlike human written ones. Training on that and testing on human generated summary news articles would be pretty expectably bad. Yeah,
I really like it is like a trade-off what you said in your framework, which is if you want to excel in specialization domains, you focus on that specific context. But if
mhm,
you want to improve in a general way all the capabilities of the model, you have to ensure diversity. And then you link this idea with the distribution of the topics themselves or the kind of data that will guide the model. I really like your paper because you tie back to the importance of data quality and the data science concepts that you have to ensure in the data set itself. And I feel in some way we are very focused sometimes on training, fine tuning, but not necessarily on analyzing these important factors in the data science part. One key thing that you mentioned before our conversation was how the concept of impossible distillation in some way is aligned with the philosophy of DeepSeek. Tell us a little bit more about that insight, please.
for sure. I guess the core contribution or the
Please
core
do.
finding is that if we want to improve a specific capability of a model, then oftentimes people think about what should we train this model on? And our setting, we consider the setting an extreme case where we don't have such data at hand. And we show that if we have a good reward, i.e., what the way to define what is a good quality data for, in our case, what is a good summary or a good paraphrase of the input document or sentence, then everything could be automated. Only if we have just such a reward, we could just let a very bad model, starting from that very bad model, we can still do some sort of training, which we call impossible distillation, to create the data set and training on it, the on that data that it generated by itself, but has been filtered with this aggressive filters that defines what is a good quality data. We can do amazing things. Many of these recent techniques, including, say, rejection sampling or reinforcement learning, which has been the driving force behind these amazing capabilities of reasoning models like DeepSeek. If we have a good way to verify what is correct and what is incorrect when the model generates something, then without access to some specific reference generated by humans, the models themselves can get this aha moment in their reasoning and generate very high quality sequences without being explicitly trained to generate such things. So in that sense, this kind of makes a precursor in terms of how models should be improved in the future, where their capabilities beyond what humans have generated as references in the web text. And we want the models to be better than humans in many of these tasks.
That is interesting because for DeepSeek, everyone was very focused on increasing inference power and creating larger and larger models.
Exactly.
But then the paradigm change, right? It's very aligned to what you proposed in 2024. I want to ask you if you have any thoughts on agentic AI. In some way, impossible distillation improves the quality of the models that power LLMs, right?
Mm.
But then what you should be concerned when you are not only want to invest in increasing inference, but want to use a data approach in possible distillation to improve the behavior of an agent.
Yeah, actually, that's something that I'm planning to work in the near future. So that really piques my interest. So both, but interesting part of training an agent is that it's really hard to collect good trajectories with which we're going to train the model on. So, for example, consider web exploration agent. We might want to hire some people from, say, companies like Scale AI, track their usage of keyboards and cursor. We're going to train the model to do the same thing when they're given the same input. But that's not really sustainable. It's not scalable enough. So oftentimes what people do is having this reasonably similar environment and then let the agent explore by itself in this environment to solve tasks. When it solves a specific task well enough, then we're gonna promote that trajectory. So it's entirely generated by the model itself. And then we're gonna give feedback, just like in impossible distillation. We generated some candidates and filtered many of the bad quality candidates out and only left the good ones, which we promoted by training on it. Agentic AI is basically trained in a similar thread where the models are generating online trajectories, and it will gonna give feedbacks to these trajectories with which we're training the model. Now, the interesting question here is, although for web tasks, it might be easier to give feedback. We can verify vision language models ourselves. We could annotate whether the model has finished the task. It's pretty simple because it's all in a simulated environment. But in a real agentic scenarios where we are, say, for example, trying to deploy an agent in a very real world like robotics like environment or some environments like including finance, it's really hard to simulate. Because of that, it's really hard to verify what's correct or incorrect. It's substantially harder. So the key challenge in training agentic AI without reliance on too much human references would be redefine good quality data. I think a lot of researchers and companies are working on this in terms of creating a lot of benchmarks and environments, but I guess there's still a lot of things to do in this space.
And is this interest of yours, such as tracing the user behavior and, and basically simplifying that in some way, and then using a similar rationale of filtering the good candidates, the good behaviors of the agent, the trend in the whole agent industry, in the whole agentic research industry? You see this as as a relevant topic?
I guess that's a super relevant topic, especially unless you want to rely completely on proprietary API-based models that are already good at, say, generic agentic tasks, and you want to train your own model, or you want to use relatively cheaper but cost-efficient models. For example, there are two ways of utilizing these weaker models. One
Mm.
is inference time scaling, where you sample a lot of different candidate trajectories and then select ones that are going to be better in the future or more likely to be successful. That's one. The second one would be training these models using the RL-like approach that I mentioned earlier, where the model generates a lot of online candidate trajectories, filter some of them, leave only some of them, and then train on those. So in both cases, we need reward model or a good way of defining good quality trajectories, whether it be training time or inference time. I think it is one of the very important challenge and trendy topics, and at least in the research area.
I see I have heard about the importance of rewarding models. And I guess it is what it makes possible, not necessarily to invest more rather than to pay attention to quality of the data as a relevant factor to improve these models. I want to ask you about hallucinations. I know hallucinations is a popular topic here. So In your
Yeah.
experiments, I guess you distill T5, and in theory, this distillation made it more reliable. And I was wondering, what steps do you recommend to further tighten actual consistency, right?
The reason we focused on summarization and paraphrasing, which is basically conditional generation, given the input information, all the information that we need to generate out of this model will be from that input document. That's the nature of summarization and paraphrasing, right? We don't
Right.
want to include any additional information. So the reason we focused on these two tasks was because at that point, people didn't really like using synthetic data set as whole as a research community. So as much as now compared relatively, we if we generate something in a tasks like news classification or sentiment analysis, hallucination might be at stake. People would say, oh, you're training on model generated data, which might include a lot of hallucinations. That was the reason why we purposefully focused on conditional generation tasks. But I do agree that for general tasks, if you're training on model generated stuff, there should be a lot of hallucinations. Even in case of summarization, factual consistency might be the key. I think it's not really a matter of data, however, but it's more about how we are actually using these models at test time that has more to do with hallucination. I think there is an open question about this, but I personally think that the way we're training the models, hallucination is somewhat inevitable because they are probabilistic machines, and there's always non-zero probability that it's going to generate something that it doesn't think is true. The way we are making them useful is lowering the probability of hallucinated content in their distribution, but there are always non-zero probability. So there's always this risk. So I think training may not be the way to mitigate this issue, but rather how we are generating more potential samples as summary examples or paraphrasing examples, and they'll filtering them out in order to detect the hallucination. The way we're decoding from these models, although we think that decoding strategy is very much fixed, like for example, we sample with some temperature or we do greedy decoding, that's it. But there has been a lot of works on how to make these models to be more faithful to the input document that we have given as an input when it's generating summary or paraphrasing by changing their decoding strategy. So I think there are multiple ways that we could adjust this hallucination behavior in both the decoding strategy and whatnot. I guess that's my long answer.
No, it was perfect, and thank you for clarifying. I was biased when I wrote this question down because I was reading about the conflict between OpenAI and the New York Times. So
Oh
the New
yeah.
York Times, it's pushing for IP rights, and I thought if I were OpenAI, what I would like is to use a similar tone as the journalist write, like this interesting, crisp tone at the moment of writing, right? Then how can you do that if you are restricted to get the data set of articles? So I thought immediately on impossible distillation and say, well, yeah, you can create a synthetic data
Right.
set. Your explanation was perfect. I want to close our conversation with a question that is more for people out there here in Stanford. Everyone is at CS is very focused on agentic AI, NLP.
Mhm.
And I would like to ask you, students that are right now building their models, innovating, what do you think they should be focusing on? What is interesting and relevant right now that we should be paying attention to?
I think what we talked about in the previous questions implicitly points toward this, but many times what is underrepresented in the scene across the AI scene is evaluation. Evaluation is a driving force behind these amazing capabilities of LLMs and agents. If we don't have a way, the way we're defining what is a good of these models, if we define a benchmark along with the metric, then about an year later, you see that all these models are climbing up the hill of this performance graph, but that doesn't make the full shape because that's only specifically focusing on specific benchmark and specific capabilities. But the best strategy might be enumerating a lot of different benchmarks that are trying to measure different aspects or different capabilities of these models. If we train a model that is good across all these benchmarks, then we are making progresses. And that's how empirically these models have been improving across all these tasks and how we're finding these models to be useful. This is also the reason why there has been a lot of improvements in small language models because we have found that for many of the tasks that we think are useful, we don't need substantially large models. Even small models are capable of doing that. Then why not just use small models? So I think focusing on what is missing in the current evaluation benchmarks and trying to make them more realistic and more up to date would be something a lot of students or potential researchers should focus on. And I think it's actually the hurdle to actually create these benchmarks are getting easier and easier because if you see recent benchmarks coming up on the papers, many like 80% of them are at least half synthesized by GPT-4, for example. It's you don't really have to hire MTurk annotators to create all the bits and bytes of these benchmarks anymore. So many of these things are automated, although we definitely need to make a good intervention to really define a good benchmark. If we put efforts on these, there should be a lot of fruitful ways to come up with successful progress.
The reason why you mention pay attention to different benchmarks, it is because you want to not be biased by the context of one specific benchmark. You want to be looking at different aspects of the performance of
The core reason would be that the definition of the good model essentially clings onto the definition of the benchmark. A good model is a very empirical concept, right? So need to be more fine-grained at core of how defining good models, not some random people coming out with own private benchmarks claiming that these models are good. We want to make better public benchmarks that are more sustainable, larger, more up-to-date, and more people are using, but we can have a better calibration of where these models are in this status quo. I guess like it's also very important because although a lot of people are trying to do something related to agentic AI, there is no consensus on how we are even defining benchmarks in agentic scenarios. Because there are so much vast possibilities of doing it. Although there are some works on benchmarks, I don't see like a clear consensus on the structuralization of these evaluations. So I guess that's the core reason why we need to be focusing on those works.
That's a great point. And I like your sentence on the model is defined by its benchmark. And honestly, when I was doing for example, this project with GPT-2, I just took some of your proposed benchmarks where I was trying to improve the GPT-2. And I think that's super useful. I want to thank you once again for this time. Hopefully, we'll
Thank
be
you.
asking questions in a future